All right, get ready for a deep dive, everyone, because today we're going to be taking a closer look at Gliese 229b.
Ah, Gliese 229b.
This one's been a bit of a celebrity in the astronomy world, kind of big deal ever since 1995,
Yeah,
when it was handed this huge award. It was the first confirmed brown dwarf.
it was the first one.
And, well, like a good mystery novel, there's a bit of a plot twist.
Okay.
And it involves mistaken identity on a cosmic scale.
Gliese 229b has been, I mean, you could say absolutely critical to how we understand brown dwarfs today.
Right.
So brown dwarfs, if you're not familiar, they're kind of like the in-betweeners of space, right?
Yeah.
So they're heavier than gas giants like your Jupiter, but they're not quite big enough to start igniting like a star.
Yeah, the missing link, basically.
Exactly. They're like right in between planets and stars.
And that's why that discovery in 95 was such a big deal.
Oh, it was huge, yeah.
Because astronomers, they found methane in its atmosphere, which is a pretty big giveaway. You usually see that with gas giants. So that kind of seemed to back up, okay, yeah, it's a brown dwarf.
Yeah.
But, and here's where it gets really interesting.
Okay.
Something about Gliese 229b just wasn't quite adding up.
It was a little strange, for sure.
Yeah.
You've got this object, and it's 70 times the mass of Jupiter, which is huge. But, and this is the weird part, it was surprisingly dim.
Yeah.
You'd think something that massive would be lighting up the neighborhood, but no, it was dimmer than it should have been.
Way dimmer.
Way dimmer.
So you've got this massive object way dimmer than it should be.
Yeah.
What were astronomers thinking back then?
Well, there were theories floating around. You know how astronomers are
Always theorizing.
always. So some thought maybe, just maybe, Gliese 229b wasn't alone. Like maybe it had a secret twin,
Okay.
a binary system.
Interesting.
The idea was that if you had two brown dwarfs right next to each other, orbiting closely, the light from both of them together might explain why it seemed so dim.
I see.
Like trying to tell how many fingers someone's holding up from really, really far away.
Right.
It all kind of blurs together.
It's hard to tell.
Exactly. And back then, the technology, well, let's just say it wasn't quite up to the task.
They couldn't quite make that distinction.
Not even close. We couldn't actually see if there were two separate objects there.
So the mystery of the dim brown dwarf, it just lived on.
It did. For a while, anyway.
Did someone finally crack the case?
They did. Eventually.
Okay.
It only took about 30 years.
Oh, is that all?
A blink of an eye in cosmic terms. A team led by some really smart folks from Caltech. They were using this incredible telescope in Chile, the European Southern Observatory's very large telescope.
Kitschy name.
Right. And they made an observation that changed everything we thought we knew about Gliese 229b.
Okay, I'm on the edge of my seat. What did they find?
Remember how everyone thought it was a single brown dwarf? Just this lone wolf out there in space?
Yeah.
Well, it turns out it's got a dance partner. It's not one, but two brown dwarfs locked in a cosmic waltz.
Wait, hold on. Are you saying Gliese 229b has a companion? It's been two brown dwarfs this whole time.
You got it. And not just any brown dwarfs.
Okay.
We're talking heavyweights here, big boys. One's clocking in at 38 times the mass of Jupiter. The other one, a little smaller, 34 times Jupiter's mass. This discovery, it completely explained the dimness issue.
How so?
What we were looking at all those years wasn't the light from one giant object. It was the combined light of two, each one fainter on its own.
Ah, that makes sense.
Like two bulbs that are individually dimmer than one really bright one.
Right.
Makes you realize how much we still don't know about what's out there.
It's amazing, isn't it, looking at something for decades and having absolutely no clue.
The universe loves to keep its secrets.
It really does.
But then technology catches up and boom.
Suddenly we're seeing double.
Exactly.
So how did they figure it out? What gave away the fact that there were two brown dwarfs instead of one?
Well, this is where it gets really cool. They use not one, but two different observation techniques, both with the very large telescope. First, they used an instrument called gravity.
Gravity.
Yeah, very appropriate name for something studying massive objects in space. It basically combines the light from four telescopes, creating one super telescope with incredible resolution. Imagine a magnifying glass, but on a cosmic scale.
Wow, so they basically gave astronomers a superpower to see what was previously hidden, so they were finally able to see these two objects separately after all these years.
Exactly like seeing two distinct headlights, where before it was just this blurry single light.
But they didn't stop there, did they? I mean, just seeing two objects, that doesn't automatically tell you they're orbiting each other, right?
Right. They wanted to be absolutely sure, so they brought in another tool, another instrument called Crier's Plus.
Crier's Plus spur.
Yeah. This one's all about analyzing light.
Okay.
It breaks down the light coming from an object into its individual colors, kind of like a prism.
Right, like a rainbow.
Exactly. And by studying these colors, astronomers can actually figure out how things are moving.
Wait, what? You can tell something's moving just by looking at its light. How does that work?
It's a pretty cool phenomenon called the Doppler shift. Imagine a siren from like an ambulance or a fire truck.
Okay, I've got that siren sound in my head.
As it's moving towards you, the sound waves get kind of squished together, right?
Right, so it sounds higher pitched.
Exactly. And then when it moves away, the sound waves stretch out.
Lower pitch?
You got it, light waves, they actually behave in a similar way.
Really? So if an object in space is moving towards us, its light would look different than if it were moving away.
Precisely. If it's coming closer, its light shifts slightly towards the blue end of the spectrum.
And if it's moving away?
Shifts towards red.
So it's like the universe is talking to us in colors.
You could say that, yeah.
So by analyzing the light from Gliese 229b with this Crier's Plus instrument,
they were able to measure these tiny color shifts. Confirmed it. The two objects, officially known as Gliese 229ba and Gliese 229ba, are in fact orbiting each other.
wow, so they're not just sitting out there in space, they're actually locked in this cosmic dance.
And get this, it's a pretty tight dance. They're whipping around each other every 12 days at a distance that's only about 16 times greater than the Earth and the Moon.
Really? That's incredibly close for objects that massive, especially when you consider how long they've been doing this without us knowing.
It really puts things in perspective, doesn't it? And remember, they're also part of that larger system, still orbiting their parent M-dwarf star, just taking their sweet time.
A 250-year-long dance around the star while doing a quick waltz with each other every 12 days. It's incredible.
It is, and it's more than just a cosmic curiosity.
Right. This discovery, it must have huge implications for our understanding of how brown dwarfs form, right? Maybe even how planets form.
You're absolutely right. The fact that these two brown dwarfs are so close together, it really challenges our previous understanding. It throws up a whole bunch of new questions about how these binary systems actually come to be.
So how do astronomers think these tightly knit brown dwarf pairs actually form? What are the leading theories?
Well, one possibility is that they form together, like siblings.
Siblings.
Yeah, imagine a giant cloud of gas and dust, a protoplanetary disk.
Okay, I'm picturing it.
This cloud starts to collapse, it fragments into clumps, and some of those clumps, they become stars.
Right, stellar nurseries.
Exactly. But sometimes you get a clump that doesn't quite have enough mass to ignite into a star.
So it becomes a brown dwarf instead.
Exactly. Now imagine two of these brown dwarfs forming close together within the same cloud.
They'd be pulled together by gravity, right?
Exactly. They'd become gravitationally bound, locked in this tight orbit around each other from the very beginning.
So they're like cosmic siblings, born from the same cloud of stellar material. Okay, that's one possibility. What about the other one?
Well, the other possibility is that these brown dwarfs, they were loners for a while, maybe formed in different parts of the protoplanetary disk.
Or even completely different stellar nurseries.
Exactly. And then later on, their paths cross.
Like a cosmic meet cute.
Huh? I like that.
And then they get snagged by each other's gravity.
Exactly. They get pulled into orbit, and voila, a binary system is born.
It's amazing to think about these chance encounters shaping the universe as we know it. But why is it so important for us to figure out how these brown dwarf binaries form? What's the bigger picture here? So it's not just about brown dwarfs then, is it?
Not at all. You see these formation mechanisms, the ones we've been talking about.
The sibling rivalry and the chance encounter.
Exactly. Those could help us understand how other binary systems form too.
Yeah.
Like binary stars, even planets orbiting other stars. It's all connected.
So by studying these brown dwarf pairs, we might unlock secrets about the formation of entire star systems, even planetary systems like our own.
It's true.
That's a pretty big deal.
It is a big deal, and astronomers are on the hunt for more of these brown dwarf pairs.
So the search is on for more cosmic dance partners.
Yeah, and let me tell you, it takes some seriously powerful tools to find objects as faint and as close together as Gliese 229bj and Gliese 229bg.
Oh, we've got gravity, right? That's got to be helpful.
Gravity is a good start, but it's just the tip of the iceberg.
So what else is in the astronomer's toolkit? What else are they using to track down these dim and distant objects?
Well, there's a new generation of telescopes and instruments coming online, some really exciting stuff. One that comes to mind is the Keck Planet Imager and Characterizer, or KPIC for short.
KPIC, catchy.
Right. It's at the W.M. Keck Observatory in Hawaii.
Okay.
And it's specifically designed to directly image exoplanets and other faint objects, like our friend the brown dwarf.
Directly image them, so we're not just looking at light curves or analyzing spectra anymore.
We still do that, but KPIC, it allows us to actually see these objects.
Wow, that's incredible. But how do you even see something as faint as a brown dwarf when it's right next to a blazing star? It's like trying to spot a firefly next to a spotlight.
It's a good analogy, and that's where KPIC really shines. It uses a technique called coronography. Basically, it blocks out the light from the star so we can actually see the fainter objects around it.
So it's like putting a blinder on that spotlight so you can finally see the firefly?
Exactly.
So KPIC is helping astronomers get a much clearer view, potentially revealing even more brown dwarf binaries hiding in the dark.
Absolutely, and KPIC isn't alone.
There's more.
Oh yeah, we've got HISPEC in the works too.
HISPEC.
The high-resolution infrared spectrograph for exoplanet characterization, bit of a mouthful.
Just a bit.
Is being developed right now at Caltech and a few other institutions.
Okay, and what makes HISPEC special? What can it do that these other instruments can't?
HISPEC is all about atmospheres. It's designed to study the atmospheres of exoplanets and brown dwarfs in incredible detail. By looking at the light passing through those atmospheres, HISPEC can figure out what they're made of, their temperature, even if they have clouds.
You can learn all that just from studying light.
Light holds a surprising amount of information. It's like these objects are sending us postcards from across the galaxy.
Postcards from space.
Exactly. And the more we learn, the more we realize how much more there is to discover.
Like with Gliese 229b, right? This discovery really throws a wrench in what we thought we knew about brown dwarfs.
It really does. It just goes to show you the universe is full of surprises, and our understanding of it is constantly evolving.
It's a good reminder to stay humble. You think you've got it all figured out.
And then, bam.
The universe throws a curveball.
Exactly. Every new discovery just leads to more questions, more possibilities. That's what makes astronomy so exciting. There's always something new to learn, something new to explore.
So what you're saying is, the next time we look up at the night sky, at all those seemingly empty patches of darkness,
you never know what might be hiding there.
We should remember Gliese 229b, what looks like just a single point of light, could actually be a hidden dance of celestial objects.
A cosmic waltz.
The universe is full of surprises for those willing to look a little closer.
That's what this deep dive's been all about.
Well said. And on that note, thanks for joining us, everyone. Until next time, keep exploring.